Topic 1.7, applying the Pythagorean Theorem. Since the Pythagorean Theorem is true for all right triangles, we can use the algebraic equation a squared plus b squared is equal to c squared to solve problems that involve any right triangles. Take this problem, for example. A doorway is 2 meters high and 1 meter wide. A square piece of plywood has a side length of 2.2 meters. Can the plywood fit through the door? Well, we know that a doorway is a rectangle, and we also know that when carrying a board through a doorway, we can carry it straight through, or we could potentially tilt it and carry it in on an angle. Okay, we're also given the dimensions of this door, so it could be helpful to start with a sketch of that doorway, to label the dimensions that we do know. Okay, and if we carry that board in on an angle, this length, which we don't know, needs to be greater than this, 2.2 meters, so that the plywood can fit through. If it is greater than that, then we know we've got a doorway that we can fit this plywood through, and if it isn't, then we don't. We need to either cut the board or get a smaller piece. So we can use the Pythagorean theorem to calculate the length of this line, because we know that these right angles are actually part of two right triangles that just fit together to form a rectangle. So really this length c here is just simply the hypotenuse of this right triangle here. Okay, so we can use Pythagoras' theorem, a squared plus b squared is equal to c squared, plug in the values that we know. These are both legs of that right triangle, so that would be 1 and 2, and simply solve for c. So that would be 1 plus 4 is equal to c squared. C squared is equal to 5. All right, so this area of a square on that length is 5, and its length would be the square root of that area, which was 5. So we can punch that in and determine that length. So that length is 2.24, rounded to 2 decimal places, meters across. Okay? C is equal to 2.24 meters across. So if we have a piece of plywood that's 2.2 meters long, we should just be able to get it through there. We'll actually have 4/100ths of a meter to spare. Let's try solving another problem. Your cat climbed a tree and needed to be rescued by the fire department. The fire department used a ladder with length 20 meters and placed the base of it 5 meters away from the tree to get the cat. How high up the tree was the cat? Now it's helpful to sketch a diagram of a problem like this so that we can help visualize the problem. So I'm just going to sketch a simple tree. I'm going to put a cat in the tree, and I'm going to lean a ladder up against the tree. Then I'm going to label the parts of this diagram that we know. The ladder itself is 20 meters long, and we know that the base of the ladder is 5 meters away from the tree. Now, we're asked how high up the tree was the cat, so we're looking for this value over here. So just by sketching this diagram of the problem, we should be able to recognize that this is simply a right triangle, and we know that the Pythagorean theorem holds true for all right triangles, so it will help us solve this problem. The Pythagorean theorem is a squared plus b squared is equal to c squared, where a and b are the two legs of a right triangle, and c is the hypotenuse of a right triangle, the longest side. So we can take the values that we do know, plug them into the Pythagorean theorem, and solve for the missing value. 5 squared plus b squared is equal to 20 squared. 5 squared is 25. And 20 squared is 400. Okay? Now, when you're left with an equation like this, you have to isolate the variable term, because we want to know what the b is. We want to know what that value is. So what we need to do is remove this extra value over here so that we're left with just b squared. And we have to remove 25 from this side as well, because what you do to one side of the equal sign, you have to do to the other. Otherwise, it's no longer a true statement. So this would be 375. So we can rewrite this now as b squared is equal to 375. In other words, if we actually drew a square out here, its area is 375. And its side length, or b, would be the square root of that area, which is 19.36. So that cat was 19.36 meters up the tree.